In this topic, we turn your EUDI Wallet KYC design into something you can actually run. We'll connect architecture to day-to-day operations, build observability into key journeys, and define CI/CD, recovery, and compliance checks that together determine true production readiness. So far, we've gone from basic ecosystem concepts through regulatory and compliance design to concrete Azure architecture and protocols. Now we shift from design to operations, turning that blueprint into a live platform that is secure, observable, and ready for real audits. Treat production readiness as part of your architecture, not a final smoke test. The goal is a platform that is observable, resilient, secure, and auditable by default. The non-functional requirements you defined earlier now show up as concrete controls. Metrics and alerts, access policies, logs, backup tests, and reports. Every critical flow, credential presentation, trust checks, KYC decisions, and manual review must be traceable end-to-end, and responsibility is shared across engineering, security, compliance, product, and support teams. In KYC, observability comes from 4 complementary signal types. Logs record detailed events when a request or component misbehaves. Metrics show trends like latency, error rates, validation failures, and conversion. Traces connect the dots, following a single verification journey end-to-end. Audit events capture the legally important story: consent, presentations, validation outcomes, and decisions. Using tools like Azure Monitor and Application Insights, these signals let you explain any KYC outcome with evidence. Structured logging turns raw log lines into data you can search, alert on, and use to reconstruct incidents. For each onboarding journey, define stable fields like Journey ID, Correlation ID, Session ID, Request ID, Tenant ID, and Component Name, and ensure those values flow through every API, queue, and external KYC or AML call. Keep logs rich in operational metadata, but never include sensitive personal data, secrets, or credential payloads. And clearly separate diagnostic logs from formal audit evidence. For wallet-based KYC, you're really running 2 systems at once: the technical platform and the business onboarding funnel. Service-level objectives should cover both. Track availability, latency, and error budgets for verifier APIs, workflow orchestration, storage, and AML integrations. In parallel, monitor each step of the funnel from wallet request to KYC decision so you can see where users drop off or get delayed. Dashboards then give operations, product, and compliance tailored real-time views of overall health. Distributed tracing tells the story of a single onboarding attempt. From the moment a user clicks Start, you attach a correlation ID and follow it through every service: the front end, wallet, verifier, trust checks, KYC, and AML engines, manual review, and profile creation. Each span records timing and outcome along the way. Reading that story, you can quickly spot latency spikes, dependency failures, retry storms, and broken paths, without ever exposing credential contents or sensitive personal data. In regulated onboarding, every important action must leave a trace. You log consent, the presentation request, what was actually received, validation outcomes, issuer checks, status checks, KYC decisions, manual reviews, and profile creation. Those events are written into tamper-resistant stores, such as immutable Azure Blob policies, and append only logs in Log Analytics or Sentinel. Keep audit evidence separate from operational telemetry and business records, and apply GDPR and AML-aligned retention policies. The verifier is more than just another microservice. It's the gatekeeper of trust. Monitoring starts with the OIDC4 VP flow. Are requests well-formed, responses complete, nonces unique, and replay checks working? Next, you watch issuer trust, certificates, trust lists, and metadata resolution. Then come continuous status checks, expired or revoked credentials, plus timeouts. Finally, anomalies are correlated into alerts and runbooks, so operators can quickly resolve failures before they erode trust. Consider a change in your AML provider. An overnight rules update ships, and by morning approval rates drop, manual review queues double, and reviewers start missing SLAs. Monitoring quickly shows the spike is tied to one provider, one rule set, and a few geographies. Because decision reasons and evidence are preserved, you can safely roll back the rule, tune thresholds, and demonstrate to auditors that controls worked as designed, catching bad changes without exposing extra personal data. A regulated onboarding platform must treat the entire pipeline as code. Application logic, infrastructure, policies, and runbooks all live in source control and move together. Every commit triggers an automated chain: build, test, packaging, multiple security scans, and infrastructure validation. Only when all controls pass does the artifact promote from development to test, staging, and finally production, with approvals and change records at each step. Compliance is enforced continuously, not as a separate project. Infrastructure as code becomes your blueprint for Azure. You describe networks, compute, databases, and security once, then redeploy them consistently with Bicep, Terraform, or ARM. On top of that, policy checks enforce guardrails: encryption, private endpoints, logging, regions, tagging, and identities. Release controls then add discipline: pull requests, peer review, automated tests, previews, and clear rollback plans. Together, these create a governed, auditable, and safe path to production. Runbooks turn chaos into choreography. For every major failure mode in your KYC wallet stack, you define a clear lifecycle: how you detect, how you triage and classify severity, how you contain the blast radius, then remediate and restore normal service. Just as important is who does what. Engineering, security, compliance, legal, vendors, and business owners all need predefined roles, contact paths, and approval steps, so incidents move quickly, consistently, and are reviewed and improved afterwards. Think of your onboarding data lifecycle as 4 linked workflows. Backups capture everything needed to restart the platform: databases, configs, evidence, workflow state, and keys. Recovery then follows clear objectives: how much data you can lose, how fast you must be back, and in what dependency order. Retention policies decide what stays, where it lives, and under which legal holds. Finally, secure deletion enforces expiry, withdrawals, GDPR rights, and cryptographic erasure. You've now taken this Azure-based EUDI Wallet KYC platform from concept to an operationally ready design. It can be observed, shipped, supported, and recovered with evidence you can trust. Next, we'll turn architecture into action, comparing tools, vendors, and open source options, planning proofs of concept, and assembling your capstone architecture pack.